But before we get into that, let's talk a little bit about transactions, and then I'm going to go through and do several of them as we'll try to break them into separate segments. So first off, every transaction in SagaChain is essentially a small program in itself. And it's a Turing-complete program. It's actually written with Python syntax, and it is running with a Python compiler and execution environment. There's some caveats to that. It's technically, we call it SagaPython. Not going to go into all the details about it right now. What's important to understand here is that you're writing a transaction that could actually send messages to any number of accounts, any number of objects. You could do entire atomic swaps, whatever it is that you want, whatever it is that's designed into it. The key point of it is that a transaction either runs to completion or it doesn't run at all. There's no halfway. This makes moving, say, multiple coins between accounts or moving any real world assets around or anything that has multiple things need to happen at the same time, guaranteed to either happen or not. So, for example, you could do a bunch of trades, and if you're halfway through the trades and the prices move, let's say, you can error out the entire trade. Simply return an error from the transaction, and it voids the transaction. It will be put into the block. At that point, if you've done that, it will eat the transaction fee, but it won't actually do the transaction because you returned an error. So every object, as we stated before, in SagaChain is stored in the object state database, is referenced by 32-byte hash values. So every object has unique ID. We call them ledger object IDs or just LOIDs or object IDs for short. So a class would have an object ID, an object would have an object ID, a metaclass would have an object ID. There's several global system objects built in. One of them is called the system account. The other one's called the SagaChain class account. There's details that are for future description. The a quick overview of the transaction itself here would be that it is a stylized environment. It has a header, which must look like this, meaning that you have to have these fields defined this is actually technically a map in Python. Think of it as a structure, named structure, and you must return it. Now, the name of it's not important, but most of the time just call it header. The name of the function has to be _header. That's what's being looked for when it's being executed. Every transaction has a primary account. That's the user account. It has to be signed by that account holder. So the user's holding a standard private key, public key. The public key is stored in the blockchain. The private for the account, the private key, of course, is owned by the user. It is possible to rekey accounts. It's also possible to have multiple signatures for accounts. The rest of these fields, although during the test environment are not being used, there will be a gas unit, that total gas units you're willing to accept, the fee per gas unit you're willing to pay, any extra fee you're willing to pay as well. There may be new fields added here before this becomes either to a late testnet or a production environment. Accounts have sequence numbers to order them. However, a future version of this will also offer the ability to submit transactions, and the transaction ordering is based not on the sequence number, but on a unique value, say the hash value of a previous block in the blockchain, to provide ordering without sequence number ordering. The next section, I'm going to skip this section for a second. The next section in blockchain that you'll normally run into is the body section. This is where your code is. This is where you can write basically the equivalent of a full program. It is always begins with a double underscore body. They do not take any parameters. And you are then writing what we call SagaPython code, which is a mix of regular Python code plus the interfaces to the object state database, which we call the class manager infrastructure, which is what interfaces the object state database. The output of it right now, although may become more stylized in the future, is a simple string output. Whatever you return in the strings gets put into the block as a set of strings. One of the best ways to do that right now is to use JSON output to make a structured output of it. As we said, we may improve that over time. This is still early development testnet. Finally, there's two more pieces. This is the last piece that you as a developer writes, you as a developer or user. And then there's one more piece, which is the signature piece that gets added as it gets submitted. When you're creating classes, so any transaction that you submit can create a new class. All classes, of course, are then global, unique, and have a global object ID, so that class can be referenced either by you or anybody else, and it supports, can be inherited from single or multiple inheritance, can be mixed in, whatever you feel like. The class structure, the class definition is double underscore CMI classes for class manager infrastructure classes. The class definition looks almost identical to any Python class if you're familiar with Python classes. However, there's a couple of very important details. It always must begin with the Saga class decorator. The class itself does not inherit. The inheritance is in the decorators, managed by the decorators, not by the classes, not by the Python statement. Every method that's exposed as a SagaPython method within the SagaChain environment must begin with a Saga method decorator. There is also a Saga field decorator, which is used to make fields specifically available. However, additionally, if you want what we call internal methods and fields, those do not use decorators. And so those become accessible only if you're in the context of the class, which means the self variable is currently of that class instance. More details to that later in other videos. Finally, the last piece, which you wouldn't see here, but you would see in the result, is the, here, let me open it up first, the tail section, which is, let me see if I can blow it up. There we go. Tail section is added by the submission, and it includes the hash of the transaction itself and a signature on the hash. The signature is based on the private key that you provide as a user. So you're signing against your primary account. It is also possible to do multiple signatures so that you would have multiple accounts and there'd be multiple signatures in the tail as well, and they can all be validated. My next segment, I'm going to go through and just use this and do a couple of quick demos of it. And thank you for your time.